Hello everyone, and thank you Kat for inviting me to speak today about stone tool technologies and gender in prehistory. I'm particularly interested in this subject as my dissertation research focuses on how people learned to make stone tools at the Epipaleolithic site of Harana IV, which was occupied about 20,000 years ago, and what that means for identity construction both individually and as a group. As part of my research, I have been flint knapping, or making stone tools, for about 7 years, have taught students to flint knap, and conducted experiments regarding flint knapping in order to determine skill and communities of practice. Today, we'll discuss the challenges that archaeologists face when working with prehistoric assemblages and review 2 case studies where gender was ascribed to ancient stone tool users. I would like to start off by giving a very brief introduction to stone tool technologies and to show you a short video on the flint knapping process.
Today, I'm working on a piece of Georgetown flint. You can see on the outside we have this Cortex, a weathered outside exterior, and then on the inside, you can see a little bit here, we have this really nice fine gray flint. I'm going to be working on a blade core today, and we'll see how it goes.
So to flint knap successfully, there are 3 main components. First is hand-eye coordination. In order to remove the flake that you want from a core, you must strike in a very precise location. This requires a lot of practice, a lot of time, and in my experience, a lot of band-aids. Second is knowledge of how rock fractures, right? So this is both generalized knowledge of how generally rocks fracture, but it's also specialized knowledge in creating particular shapes, like one of those cores that we were just looking at. And finally, the third piece is knowing how and when to use the various tools from your flint knapping toolkit, right? So switching in between hammerstones and billets is incredibly important for creating the tool type that you're aiming to create. You can see strength is not necessary for being a successful flint knapper. Generally, patience and planning lead to better results than brute force.
Let's look at the products from today's flint knapping. Here we have a core, which is what the blades ultimately get struck off of. This is shaped through various removals of flakes and blades. Next, we have debitage, the waste products of flint knapping. You can see we have lots and lots of debitage that was produced from a single core. A lot of these are very sharp and can be used for other types of tools. And finally, we have the blades. These are very sharp tools that can be used for a variety of activities like butchery, construction, and hunting. Here I have for you a scrap of leather. I'm just going to pick a blade from these blades that we've made from this core, and really I'm going to just show you how easy it is to cut through leather. These are incredibly sharp tools and very, very easy to turn into a variety of other tool types.
So what are lithics? Generally speaking, there are three main types of stone tools: curated, expedient, and ground stone. Curated tools take a long time to make and are kept and used repeatedly. They're often the artifacts that you would see in a museum. So here we have a Clovis point, right? And so this is a North American point, and you can see with all of these tiny little removals through here that somebody spent a lot of time and a lot of skill in order to create this flute. Basically, this is a tool that somebody's going to keep around for a significant amount of time, or to show off to other people. Next, we have scrapers, right? So this is something that you're going to use for a while. This is like a Neolithic end scraper, and basically used for processing things like hides and leathers. We have a blade core, so similar to that blade core that we just saw in the video. And then finally, we have a pre-dynastic knife from ancient Egypt, right? Again, you can see all of those really fine removals, and this is quite a thin piece. This is going to take a lot of skill and a lot of time to create. The second group, expedient tools. These are often pieces of debitage that have sharp edges and can be used as cutting and scraping tools, right? Expedient tools are extremely common. They are much more common than these curated tools, right? And they tend to really be single use. So you can think of them as plastic knives of the historic era. Finally, we have ground tools, and so ground tools are a little bit different. They take a lot more time in order to produce because they're produced through a combination of percussion and grinding. So in order to get the rough shape, you basically kind of strike them like you would flint knapping, but then there's an additional component of grinding it down until it's the correct shape for the particular type of work that you're doing. So here we have a ground stone axe, and so used for chopping, right, how you would use an axe. And then down here we have a ground stone, like a mano en metate, which is really for oftentimes grinding food products, but you can also use them for grinding ochre for paint or other plant fibers. The last thing that we find probably more than anything else as archaeologists is debitage, right? Debitage itself is the waste product of flint knapping and can be used to make expedient tools, or it can just be discarded. This photo is an image taken from one of our excavation seasons at my dissertation site of Harana 4, and as you can see, in 1 square meter, there's just hundreds and hundreds of pieces of debitage. For us, it's really important to be able to have the debitage in combination with the tools to try to understand what's actually happening during the daily lives of the people that we're investigating. So then the next question is figuring out what people used those tools for, right? And in order to determine the use of these various types of tools, we can use different types of lithic analyses. The first one of these analyses is residue analysis, right? Residue analysis can determine the material traces left on stone tools, things like animal fats, blood, sickle sheen from cutting plants, phytoliths, protein residues, and starch residues. This image here, you can see this is an archaeological flake that archaeologists were investigating. They put it under a scanning electron microscope to try to find lipids and lipid residues. It's pretty interesting. You can kind of see there's a little bit of sheen here, and they're really investigating the edge and what's building up on these edges and in these little nooks. And you can see there's this little hair that actually got preserved with this, and so they ended up investigating that. Next is use-wear analysis. Use-wear analysis can determine the type of work a tool was used for by looking at the type of damage the edge suffered during its use. This knowledge is produced through experimental archaeology, where modern archaeologists make and use stone tools intentionally to study the effects various activities like butchery, woodworking, and antler carving have on the edge of a biface or other type of stone tool. In this image, researchers actually produced these bifaces and then used them on different materials. So I believe it's like leather and meat that they used in order to determine the difference between a tool that was used for cutting leather and a tool that was used for cutting meat. Finally, experimental archaeology or experimental work can be used to determine how stone tools were used in the past. Archaeologists make stone tools and then test them in a variety of situations. They compare the archaeological record to what they were able to produce in these experiments and try to determine things like the use-wear analysis or the residue analysis, but they can also look at things like physical movements. So in this example here, we have archaeologists testing different hammer stones and the physical movements that individuals may have used in order to utilize these stones. As researchers working in the ancient past, we face a number of challenges, especially when trying to research topics based on cultural constructions like gender and gendered labor. First, unfortunately, we have no texts. There are no texts left to us by prehistoric flint knappers, and there's just generally no way for us to be able to engage in that type of line of evidence. Second, we've got preservation biases, right? There are significant preservation biases. Organic materials like bone, wood, and shells, which can all be used for tool making, they degrade over time. Rocks, on the other hand, are very durable and degrade very slowly. So this can skew the archaeological data as bone, wood, and shell tools are potentially underrepresented. Ethnographic analogies, so no reliable ethnographic analogies is something I'd really like to spend a little bit of time on. These analogies can be useful if they're utilized cautiously. Ethnography is based on modern peoples who have complex histories. While ethnography can help researchers try to understand the past through different perspectives or give meaning to practice less familiar to the archaeologists, we must be cautious in applying ethnographic findings to the ancient past. All cultural groups change and respond to social, environmental, and knowledge changes. These changes may occur at different times or rates depending on the unique historical, social, or environmental conditions that the group has experienced. Therefore, it is irresponsible for researchers to simply apply modern culture to the ancient past, no matter how similar the groups may appear on the surface. Finally, we have oral histories. There are some places in the world where oral histories, ideology, and mythology reach back in time quite far. While these histories can be helpful in situating past practices into daily life, they're generally only applicable to the group of people that they belong to, and in many places, deep time is simply not accessible through this particular line of evidence. I'm going to show you here, we have an epipaleolithic hut. So this is ranging from like 20 to 18,000 years ago, and you can see what we have remaining. This is basically the outline of a hut structure, this darker area here. And then on the inside of this structure, you can see we've got lithics. So we have these kind of knapped lithics and various other tools, and then a grinding stone. And a lot of times, this is pretty much what we have left when we're dealing with deep time and prehistory, right? Because those organic materials fade away quite quickly. So now, let's talk about gender and the ancient past. I have a few images up now about stone tool use. These images are the result of a Google search I did using the term prehistoric hunting. If you notice, none of the images portray women using or making stone tools. Women in these images are doing domestic labor, like making clothing and cooking, or are absent altogether. So we'll see we've got these two ladies here who are cooking, and then we've got this one here who is making clothing, and then in general, then they're kind of missing everywhere else. The idea that men were hunters and women were gatherers generally came from the book Man the Hunter, which was written in the 1960s. The ideas from this book are based in ethnography, which I noted earlier is problematic to apply directly to the ancient past. Women as gatherers also supports the cultural perspective of earlier researchers, where women were thought to naturally belong in the domestic realm. We need to move away from these assumptions and base archaeological interpretations on data, lived experiences, fact, and the choices that people made within their cultural contexts. So on this slide, I've got a couple of women using stone tools. Finding these images was significantly harder than finding the other images of people hunting, right? Here, we've got a woman using an atlatl to hunt some llamas. We have another woman back here who's using stone tools to process some ivory from a mastodon. And then finally, up here, we've got an image. This is actually an archaeological artifact from La Vache Cave in France. It's about 13,000 years old, And we can see we have 2 men and a woman who are hunting a reindeer. So at this point, the question really is, can we determine the gender of a flint knapper or a stone tool user? Feminist archaeologists have proposed the following method to gain a better understanding of the role gender played in the ancient past. There's an emphasis on the context of a site and the processes that took place at the particular site. I'm going to specifically talk about lithics here. First, researchers must learn as much as they can about a single site. This includes time period of occupation, mobility patterns, architecture, activity areas like butchering, flint knapping, and cooking. Right? Then, the next step, researchers should investigate the various activities that took place at the site. For flint knapping, researchers are going to look for things like where raw material came from, the methods that were used to flint knap, the types of tools people used to flint knap, where the flint knapping took place, and sometimes the skill of a flint knapper. As part of this investigation, it is imperative to research the chaîne abattoir, or the chain of operations, used to make the final tool. This is a technical approach to understanding the mental templates and the cultural constructions around the practice of flint knapping. Variability in chaîne abattoir can indicate different intentions of a flint knapper, so like making a knife versus making an arrowhead, right? They're going to have 2 very different ways of approaching that final tool shape. Different cultural groups using the same site and utilizing their own knowledge. So we have potentially different people who learn how to make a tool in different ways, and they come together and have different chaîne abattoirs there because they learned differently. Different religious or ideological intentions for a final tool, or the skill of a flint knapper. All of these can really cause some variability within that chaîne abattoir. Considering the potential religious, ideological, and symbolic aspects of an activity is important here. For example, a knife made for a ceremonial purpose may be made differently than a knife intended for food processing. Finally, archaeologists must compare the findings from one site to another site nearby. Right? This allows for comparisons to be made and for critical and crucial analysis to the various activities that occurred within each site and kind of situate them all together. By following these steps, archaeologists can get closer to situating mundane activities like flint knapping into daily life and begin to investigate engendered labor. It's incredibly difficult to identify gender in prehistory, and even more complicated when we take into account the possibility of non-binary gender construction. This approach does not always allow for determining the gender of an individual, but it does allow for the interpretations of social agency in the past. With the background material covered, let's explore some case studies, one from Epipaleolithic Israel and the other from the early Holocene in Peru. All right, let's get into some case studies. The site of Ohala II is located in modern-day Israel, just southwest of the Sea of Galilee. It is about 13,000 years old and is very well preserved stratigraphy and organic matter. Multiple huts, hearths, and activity areas with at least 1 human burial were excavated at this site. You can see, right, we have the Mediterranean Sea here. This is the Sea of Galilee, and then right on the edge is Ohala II. So here are some of those hut structures that we were talking about, and this light gray here are some other features, and we have that burial right in the middle. So this first image I have up is a density map of the lithics. You can see that the density of the lithics is really high in the southern end of the hut, and significantly lower once we get to the northern end of the hut. The second image is for basically, it's the same as a density map of the exact same hut, but it's looking at various types of grains. So specifically wheat, barley, seeds, and other kind of less common grains. You can see that the density of these grains is much higher around this ground stone tool. So it's very high around the ground stone, it's low in the middle, and then it gets higher again in the southern end of the hut. The researchers interpreted this data to mean that there are 2 different practices that took place and were spatially separated. This is really reasonable, and it's a very viable conclusion based off of the information that we have. However, it does become problematic when ethnography, in essence, is copy-pasted into an ancient practice. This image was produced by the authors of the paper, and they suggest gendered labor, men flint knapping and women processing grains. You can see the gendered labor that we've got going on. And here's a quote from the paper. You can go ahead and read it yourself, but I'm just going to talk about it really quickly. In general, this is a reductionist approach to ethnography, deep time, cultural complexity, and gendered stereotypes. So not only are the interpretations stated as fact, that women worked as grain processors and men worked as flint knappers, but they also claim to be the oldest evidence of gendered labor based on the distribution of lithics in plants alone. This is a problematic approach to engendering lithic technology because it is completely based on modern ethnography. While it may be possible that this was indeed the case, it's not evident from the archaeological remains that the work was gendered. Our next case study is Willamaya Puccha. At the site of Willamaya Puccha, near Lake Titicaca in Peru, archaeologists excavated a 9,000-year-old site and found the remains of 6 individuals buried in 5 graves. More than 20,000 artifacts, most of which were lithics, and 10 cultural pit features were also excavated. Only 2 of the 6 individuals that were buried with projectile points and hunting toolkits. The other 4 individuals did not have any associated grave goods. Using biomolecular methods, they determined that the individuals buried with the hunting toolkits were female. One was about 17 to 19 years old, and the other was 25 to 30 years old. For the sake of time, we'll only look at the 17 to 19-year-old individual. Here, you can see a burial pit. She is situated with her skull over here, and then her long bones, so her legs down here, and right in the middle is likely where her arms would be. You can see there are 2 projectile points located right around where her arms would be, and it's not known whether she was buried with them as grave goods or if they're potentially indicating injuries. So buried with her, she had 7 projectile points, a couple of flakes, so it's unknown whether these are expedient tools or debitage. There's a couple of scrapers, so tools used for preparing leathers or other hunting tools. We have some burnishing stones, some ochre, and some chopping tools. So the way that the authors investigated this, they recognized that big game hunting is a male-biased behavior in ethnography and wanted to test the long-held notion that big game hunting was strictly a male activity. They sampled 27 human burials in the Americas that were associated with big game hunting tools. So you can see here the ones that have color are individuals who had hunting tools, and the ones in white are individuals who did not have hunting tools associated with their burials. Red circles are women with the tools, blue triangles are men who have the hunting tools, and then green is an unknown sex. And so they're just kind of counted in. So what we ended up seeing is 16 of those burials were male and associated with hunting tools. 11 of the burials were female and associated with hunting tools. With this data, the researchers found that it was highly unlikely for big game hunting to be a male-dominant activity during the early Holocene. Rather, women most likely made up 30 to 50% of the big game hunters, peaking around 40%. Through micro-scale investigations of human burials, looking for variability within the burials, considering the ideological or social aspects of the burials and stone tools, and then comparing the findings to other Paleo-Indian sites, these researchers came to a very different conclusion than what we saw in the first case study. So as you can see, our 2 case studies came to very different conclusions regarding the female involvement with stone tool technologies. The more lines of evidence that we can draw upon as archaeologists, the more reproducible our research becomes. This is why it's important to situate ancient behaviors within their respective cultural context through rigorous archaeological investigation. I'm not arguing that lithic technology was never gendered. Rather, it is important for archaeologists to acknowledge their biases and to work to reduce the impact of their biases on the archaeological record. We must consider that people in prehistory did not designate their daily labor based on modern gender constructions. Currently, there is no way to determine the gender of a flint knapper or stone tool user, and it is our responsibility as archaeologists to interpret our findings with minimal bias. To do this, we must be critical about our theoretical, practical, and cultural approaches to the archaeological record. Now, in the last few minutes, I'm going to pull up a 3D model from Harana 4. This is an actual artifact that I made a model of, and people used this tool 20,000 years ago. While looking at the model, I would like for you to do a little bit of lithic analysis on your own and consider the following questions. 1. What could this tool have been used for? 2. What evidence would support this? 3. Who would have made or used this tool? And then finally, kind of think, what assumptions did you have to make in order to answer these questions? I look forward to hearing some of your responses. So here, you can see that tool that I was just talking about. And we have this end here, which is kind of blunt. And then this back, which is that outer cortex layer. And then this sharp edge right along here. See, it's pretty sharp, and there's also kind of some blunting here, so it comes to a point and it's a little bit blunted across this edge here. And very quickly, I would like to show the works cited for all of the works that I did cite today. A lot of this research is really fantastic, and I would highly recommend reading up on some of these if you were interested in any of it. I can also email you the list of readings if you're interested. Well, thank you, and I look forward to chatting with you soon.